Welcome to our Q News video podcast. As part of our Back to Basics series, today I'm going to talk about UPSs. A UPS is an uninterruptible power supply. UPSs are used to keep your equipment up and running during a power outage. To understand how a UPS works, let's first look at the equipment we're trying to protect, the equipment we're trying to keep online. Typically, these are computers and peripherals, your monitors that you need to perform work or whatever it is you're doing. There's three basic types of UPSs on the market today. There's a standby UPS. These are the ones you see at Walmart, Best Buy. They're relatively inexpensive. And the way they work is power comes into the UPS. Almost all of them nowadays have some power conditioning, which amounts to a surge protector. So if you get a big spike, it'll take the spike out of the signal coming in. Then the power goes to what's called a transfer switch inside the UPS. And out of that transfer switch, it goes to your computer, your monitor, whatever device you're trying to keep up during the power outage. Along with that, the AC that's coming in is going into something called a bridge rectifier. That bridge rectifier is used to charge a battery. And that battery then drives some type of an inverter that gives you an AC signal out, and that signal then goes to the transfer switch. If we lose power, the transfer switch is going to kick over, the inverter is going to kick in and provide power to your device. Typically, 99.999% of the time, these standby UPSs do not put out a pure sine wave. They put out a simulated sine wave. Not very clean, not very good for really sensitive equipment, but for most things, it works just fine. For a consumer-based type computer or workstation, they're okay. The next level of UPS is similar, and it's called a Lineinteractive. We still have the power conditioning. Power comes in, goes through a surge type protector, cleans up the power. From there, it goes into an auto transformer. There's multiple names for these. Sometimes it's called an AVS, automatic voltage regulator, or automatic voltage source, or an AVR. And out of that AVR into the transfer switch, and then to the computer. Very similar. That power that comes into the UPS also goes to a rectifier. The rectifier goes to a DC source that charges a battery. That battery then drives an inverter. Typically in these devices, the inverter is much better. That goes into the transfer switch. Again, power lost, transfer switch kicks in, and we're now running off the battery. What's really nice about the Lineinteractive ones is you've got the surge protector that takes care of the peaks. And if there's a sag in the voltage, we have this auto transformer that's switching tabs that keeps the voltage clean through the sag. So we're taking care of the peaks, we're taking care of the sags. And if the sag is too much, then it will kick on and go through the inverter, and the transfer switch will kick in. What this means is that your battery will be saved until it's really needed, and all the little fluctuations, or if it's a minor brownout for a little while, it's not going to go in the battery, which means you'll get an extended battery life. Every time a UPS takes a hit, we're actually diminishing the total useful life of the battery that's in this device. Not a great analogy, but a decent analogy is think of a UPS and its capacity like a loaf of bread. Every time it kicks on battery and goes into the power kickover mode, we're taking a slice of bread out of that loaf until eventually that useful life of the UPS is diminished. The next type of UPS, which is typically found backing up servers, critical equipment, and always typically in a data center, is an online double converging UPS, also just sometimes called an online UPS. What it does is it brings in line from the utility, plugs into the wall, in other words, or some fancy type of jack if it's in a data center, goes into a rectifier, goes into a charger, charges the battery. The battery gives us our DC output, and that goes into an inverter. And the inverters on these guys are very, very pure sine wave, clean output devices, and that drives your equipment. So regardless of what's coming in from the utility, from the power company, your output is always going to be a very, very clean waveform, taking care of all your sensitive equipment. There's absolutely no time for failover. You lose power, it's already running off of the battery. Almost no chance of loss of power to your device. Next topic. UPSs have batteries in them. That's the magic sauce that keeps the battery powering up your equipment, technically powering up the inverter, which powers up your equipment. Depending on the technology that is used in the batteries, typical battery shelf life is 3 to 4 years. So from a maintenance perspective in a data center, even in your small office, you should try to date code and have on your checkoff sheet every 3 years, 3.5, 4 years. If you haven't replaced the batteries on the UPS, you should either replace the UPS or replace the batteries in the UPS. UPSs are absolutely critical to keep your systems available during power outages. They also condition power. We use UPSs on just about all our equipment here at Quinexus. We sell lots of UPSs every year. If you have questions about UPSs, feel free to reach out to me or one of my associates here at Quinexus, and we'll be happy to help.